Hello and welcome. Today we're going to continue our exciting adventure with computer networks, connections and protocols. We're on to lesson 7, modes of connections, which is actually the first part of wired and wireless networks, protocols and layers. A lot of stuff to get through. Let's get started. So we have a look here. This is the exam spec and we are going to be studying this right here. So essentially, all networks work in the same way. A device prepares a data signal to send to another device, and this is transmitted along cables or wirelessly until it reaches its destination address. This transmission is controlled by what we call protocols. These are sets of rules that define how the data is transmitted between devices across a network. Data can be transferred from one device to another via cables or wirelessly, and different protocols are used for each type of transmission. We need to know about wired and wireless network transmission. Wired is typically via what we call Ethernet, and wireless will be via Wi-Fi or Bluetooth. Starting with the wired connections. Ethernet is the traditional protocol used to connect devices in a wired LAN. So that cable that you can stick into the back of the PC that we call an Ethernet cable is technically a CAT cable. Ethernet is the software protocol that is responsible for the rules that transmit the data across the cable. So Ethernet defines how data should be physically transmitted between different devices using MAC addresses to determine which device the data should be sent to. Remember, a MAC address is hardwired into the network interface card of a computer device, and that tells it the address on a local area network. Not to be confused with IP addresses, which give you the address on a wide area network. Ethernet also defines what should happen if data collisions should occur on the network. So if two computers are sending at the same time and those data packets interfere with each other, what happens next? What are the advantages of Ethernet? Well, you get a stable connection because it's wired. It's more secure. You actually have to be physically in the premises, plugged in using that Ethernet cable before you can access it. You get faster data transfer speeds and usually better signal quality. It's a wired connection, it's all shielded, it's fast, it's reliable. Disadvantages: it can be more expensive to install than, say, wireless. Okay, if you have a look at this picture here, buildings have to be wired up. You need cables through walls, through floors, along ceilings. More difficult to add extra devices. Obviously, once you're plugged in to the cable, devices can only be used in one location. They're not portable or mobile. Moving on, we've got Wi-Fi with wireless. So Wi-Fi stands for wireless fidelity, and this is a set of protocols that define how network devices can communicate wirelessly using radio waves in the electromagnetic spectrum. All sorts of devices can make use of Wi-Fi connections. That could be laptops, tablets, smartphones, desktops, video games, consoles, e-readers, anything you can think of really that you can add a computer chip to. The Wi-Fi protocols determine the frequency band and channel that should be used. We'll look at that in a second. The data transmission rates. How devices should be authenticated when they attempt to join a network. Wi-Fi uses electromagnetic radiation, radio waves, as I said before. Typically for Wi-Fi, signals are transmitted around 2.4 GHz and the 5 GHz wavebands. Each specific frequency is given a channel number for convenience. And that's something you're used to. If you look at TV channels or radio stations, we give them a channel number, BBC 1, BBC 2. Radio 1, Radio 2, Radio 3, Radio 4. Channel numbers are easier to remember than frequencies. Okay. If you look at the picture here, we've got the range of channels available at 2.4 gigahertz, and you can see there's a range of different frequencies, a range of different channels. If you are kind of plus or minus 11 from that frequency number, you can receive and transmit on that channel. Okay. Signals transmitted on the 2.4 GHz frequency have a greater range, but lower data transmission rates than those using the 5 GHz frequency. In order to communicate, two devices must be transmitting and receiving on the same frequency. Stands to reason. Adjacent signals can cause interference. So if you and your neighbor are both using Wi-Fi, it's both using channel 8, for example, then they can interfere with each other, okay? But luckily, most modern Wi-Fi devices will move to a different channel to minimize interference from nearby network signals, and they'll do that automatically without you having to interfere. Advantages of Wi-Fi. Well, the cheap setup costs are great. You need the wireless access point. You can install that, and that's really all you need to know. It has less impact on the physical environment as no extra wiring is needed. You can easily connect multiple devices without the need for extra hardware. And users can move around freely and work in multiple locations as long as they're within range of the Wi-Fi signal, and can handle a large number of users. It's scalable, it can support 2 or 3 people, it can support lots of users. Bearing in mind, of course, that the total bandwidth available is shared between that number of users, so obviously more users will get a slower service. But there are disadvantages. Compared to wired Ethernet connections, Wi-Fi tends to have slower data transfer speeds. Bandwidth is, as I've said, shared amongst connected devices, and that's not necessarily predictable. You don't know exactly how many devices are going to be connected, especially if you're at a busy university or school or somewhere like that. You might get a better or worse connection. The connection is not as stable because you're going to get interference from other networks. Signals can be obstructed by walls and floors and building materials. It's also less secure than a wired network as it is more vulnerable to hacking. Anybody within a range of even 100 meters from the wireless access point could intercept data packets if they're not encrypted. Again, we know this from just our own personal experiences, but as you wander around your house, if you're close to the wireless access point, you get a really strong signal strength. If you go into the back room in the attic or something like that, that signal strength cuts in and out. You don't get such a good speed or such a reliable connection. Remember, it is very easy to intercept wireless signals, and so most wireless networks are encrypted. So when a device needs to connect to a secure wireless network, you need to enter a Wi-Fi password. So we're used to doing this in our house or when we visit friends, etc., when you go to school or go to university. Now, the wireless network password or network security key must be entered correctly to authenticate the device. So it knows you are who you say you are and you're allowed to access the network, and that allows you to connect to the wireless network and start sending and receiving data. The Wi-Fi network then uses a unique encryption key to scramble the data that is sent over the network so that if it's intercepted, it doesn't make sense and cannot be used by others. Only devices with that correct encryption key can decrypt the data. This is controlling the data transmission between your device and the wireless access point. Okay, this is not about how the greater internet is encrypted. This has nothing to do with HTTPS or anything like this. This is simply your connection from your device to the wireless access point and back again. There are many types of Wi-Fi encryption. It's always an arms race between the hackers and the security experts. WEP, WPA are kind of old and broken. Most people nowadays will be using WPA2 or WPA3. Those are the latest up-to-date standards and are secure. Another type of wireless connection you could use is the Bluetooth family of protocols. Bluetooth is another form of wireless protocol that can be used over short distances using ultra-high frequency UHF radio waves. It is secure and does not require a clear line of sight between the two devices. Common uses of Bluetooth are connecting Bluetooth headphones to a device, streaming audio to Bluetooth speakers, and sharing files between mobile devices. The advantages of Bluetooth is it's quick to pair devices, data communication is more secure than open unencrypted Wi-Fi, and obviously it's free to use if all the devices support Bluetooth. You don't need any additional hardware to buy and install. If your phone has Bluetooth and your headphones have Bluetooth, you're good to go. Disadvantage, only works over a short distance. It's much smaller distance than Wi-Fi. Also has much lower bandwidth than Wi-Fi, especially modern Wi-Fi protocols. In summary, there are different modes of connection. Wired, such as Ethernet, and wireless, such as Wi-Fi and Bluetooth. Wired connections offer faster and more stable connections. Wireless connections are more flexible, but tend to offer slower and less reliable connections. Security is also a bigger concern with wireless connection. I hope that was useful to you. I will see you in the next video. Good luck with your studies.